You know that old TV remote sitting on your coffee table? Well, it's not just sending out simple commands. It's actually speaking a secret language, one that's made of invisible light. And in this explainer, we're going to learn how to speak it fluently.
See, every single time you press a button, you're not just sending a code, you're transmitting a whole structured sentence. Over the next few minutes, we're going to decode that sentence. And more importantly, we're going to uncover the one big reason this simple process confuses even the most experienced makers out there.
All right, so our journey starts right here, at level 1, capturing codes. This is basically the front door for anyone with an Arduino and a little bit of curiosity. And getting started is actually way simpler than you might think. You just hook up this tiny 3-pin IR receiver to an Arduino, you upload a standard library example code, and then you open up this serial monitor. That's it. You're ready to start listening in.
Okay, so you point your remote, you press the play button, and bam! A number just pops up on your screen. In this super common example from a tutorial, that number is 64. You press it again, you get 64 again. Seems simple enough, right? We've captured a code.
But this is where the real mystery begins. We have a number, but what does 64 actually mean? It's not just some random value, it's a clue. And to really understand what it's telling us, we've got to go deeper.
And that brings us to level 2, seeing the signal. Now we're going to go behind that number and look at the physical signal that's literally flying through the air.
You see, that number 64 is just a convenient summary. The reality is a physical signal, a super precise pattern of on and off pulses of infrared light. Seriously, just think of it like Morse code, but instead of sound, it's invisible light. And instead of dots and dashes, we're talking about very specific pulse lengths.
At its absolute core, what we're dealing with here is a digital signal. And if you have a tool called a logic analyzer, you can actually visualize this stream of on and off states. This is the physical truth behind that simple number we captured a second ago. So how does that invisible flashing light turn into data? Well, it's all about timing. A logic analyzer shows us that a short pulse followed by a short pause represents a binary 0. But a short pulse followed by a long pause, that's our binary 1. It's this exact sequence of ones and zeros that builds the number that we see on our screen.
Okay, so now we have our ones and zeros. But, you know, a long string of bits is really just noise without some rules. And that brings us to level 3, protocol grammar. These are the rules of the IR language. Think of a protocol as the grammar that gives our binary signal meaning. It's what dictates how many bits are in a command and what each little group of bits represents. It's what turns that random-looking string of ones and zeros into a coherent sentence that your TV can actually understand. Let's look at a classic example, the Philips RC5 protocol. It uses a 14-bit structure, and these bits aren't just one long number. They're broken up into these meaningful chunks. You've got a 5-bit address that basically says, hey, I'm talking to the TV, and then you have a 6-bit command that says, and now I want you to turn the volume up. This is that grammar in action.
Okay, so we've got the code, we can see the signal, and we even know about the grammar. It should all be crystal clear now, right? Well, this is where almost everyone gets completely stuck. This is the source of all the confusion.
This quote from a user on an Arduino forum just perfectly captures the problem. They captured a hex code, which is just a shorter way of writing a long binary number, but the software they're using is expecting a totally different format. It feels like they're speaking two different languages, even though they're using the very same remote. So why is that?
This right here is the central question. How can one physical button press, just one single flash of infrared light, produce these wildly different codes depending on which program is listening? The answer to this is the key to mastering this entire topic.
The answer, which was so brilliantly explained by researcher Ken Sheriff, isn't in the signal itself. It's all about the interpretation. So on one hand, you've got official decoding. This is what the manufacturer intended. It breaks the signal into logical parts like device 17 and command 56. But on the other hand, you've got bit decoding, which is what most hobbyist software does. It just reads the whole stream of bits as one long number, basically because it's just easier to process that way. And this right here is our Rosetta Stone. This is the big aha moment. For one single press of a Sony Remote stop button, the exact same physical signal can be correctly interpreted in 3 different ways. The official way is device 17, command 56. But a simple bit decoder just reads it as the hex value 0x1d1. And another common decoder might even read it as 0x08. All 3 of these are valid interpretations of the exact same signal.
I'm going to say that again because it's so important.
It's not a different signal, it's just a different way of writing it down. The entire confusion that sends people spiraling into forums isn't a hardware problem or a signal problem, it's a translation problem.
And once you really understand that, you're no longer just a hobbyist capturing random codes. You've basically become a universal translator. You can look at any code in any format and know exactly where it came from.
I mean, think about the journey we just took. We started at level 1, just capturing a simple number. Then we leveled up to level 2 and saw the raw pulses of light. At level 3, we learned the grammar of protocols. And finally, we defeated the final boss, understanding that one signal can be written down in many different but equally correct ways.
So now you have the key. You can decode, translate, and understand the secret language that's hiding in plain sight all around us. The only question left is, what forgotten remote